Okay, I have started Arduino and I've loaded the files that we've downloaded from GitHub for a single channel gateway. What we're going to do is we're going to modify this project to suit our needs. I'm in Singapore and the allowed frequency band here for LoRa is 915 megahertz. The default project configuration actually sets it at 868 megahertz, which is the European version. So we're going to work with these files that we have in Arduino so that we'll be able to fit it into the 915 frequency band. The first thing that we need to do is basically look at ESP32 Gateway.h. It contains some definitions on how our ESP32 is set up. The very first thing that we need to look at is the spreading factor that we're going to be using. We're going to be using SF7. Collision avoidance, channel activity detection is set to 1. And this thing is the most important thing. We have this definition of the pin out or the pin mappings, which we are going to modify later on to suit our ESP32 board. Okay, I'm choosing pin out 3, which is actually defined somewhere here in the LoRa modem.h. So as you can see here, we're choosing to use pin out equals 3, which is basically the pin mappings of our Heltec ESP32 LoRa board. Next thing that we need to look at is the let's go down. The next thing that we're going to look at is the address of the TTN server. Here we're looking at router.as1.the-things network. This is basically our TTN router in Southeast Asia. And the next thing is, of course, your gateway profile. I've added my email as well as, okay, the latitude and longitude coordinates are not set. Just set it as default. And then we have the NTP time server here, which I pointed to st.pool.ntp.org, which is basically the NTP server here in Singapore. And you also need to set the time zone. Okay, going further below, we set the Wi-Fi our gateway is going to be connecting to. So you need to set the SSID as well as the password for your Wi-Fi so that your gateway will be able to forward packets received from any of your sensor nodes to the Things network. Okay. Also, another thing that you need to look at is the LoRa modem.h. At the very beginning of the file, it defines a set of frequencies that you need to use. By default, the frequencies that are being defined in GitHub is suited for the European version, European market. I've commented all this out, including the 433 megahertz band. And then I've defined the frequencies that we will be using for this particular gateway. In this case, I'm using 923.3 megahertz. So as you can see here, the FREC that I'm going to be using is actually FREC 2, which is equivalent to this thing. Okay, since it's a single channel gateway, there are actually a few limitations. First and foremost, of course, you cannot use multiple frequency in this case. The band that you're going to be using is specific only to 923.3. If you have a LoRa node, for example, or a sensor node that publishes at frequencies 9023, you will not be able to receive them. Your gateway will not be able to receive them. If your LoRa node, for example, is operating on, if it uses frequency hopping, hop from one frequency to another within the same band, then sometimes you would lose packets. You would lose notifications to TTN. And also, another thing, since it's a single channel gateway, the limitations also include that the gateway is not able to process downlink messages from TTN to your node. Unlike in a proper gateway, which I had obviously a few months ago, till I loaded to somebody else, that thing was able to forward downlink packets to your LoRa node. So you have to remember these kinds of things when you're trying to build a single channel LoRa gateway. Okay, so now that we have modified all those things, then we can flash our board with the single channel gateway firmware. First thing that we need to look at is we go into tools and make sure that the board is properly set up. Okay, I've used ESP32 deb module. I've set the correct port as lab to UART. Then I should be able to verify, compile, and upload. I'm just going to go ahead and do an upload. It will compile the code anyway. So right now it's compiling our sketch. It may take some time to upload it to the board. And I will just leave that one here